Sum of exterior angles of a polygon. Following our previous lessons on types of polygons as well as interior angles, we will now move on to learning about exterior angles. So what exactly is an exterior angle? We call the property exterior angles of a triangle that we have learned in our previous chapter. The exterior angle is the angle between any side of a shape and a line extended from the next side. Now that's a lot to unpack, isn't it? How about I show you in a diagram? So let's say we have a triangle here. Now if you recall, the exterior angle of a triangle will look something like this, where we extend the line further to a point, any random point, and then we label the angle. Now let's say we change our point of focus to the next vertex over here, right? So we can also extend the line outwards and then label the angle. And now we can do the same for the last side. And the same can be said for any other polygon. Let's say we have a pentagon. Then the same rule applies, in which we can extend the line outwards and then indicate the angle between the dotted line and the side of the shape. And this can be applied to all of the other vertices. And beyond the pentagon, we also have many other figures or shapes that can be 6, 7, 8, all the way to n-sided, in which we can also draw the exterior angle as such. Therefore, we have now covered what an exterior angle is, which is 180 minus the interior adjacent angle, or diagrammatically, you would see it as drawing a dotted line outwards from one of the sides and then indicating the angle between the dotted line and another side of the polygon. Now that we know what is an exterior angle in a polygon, we can look at some useful results to solve some problems. Now, one of these results is that the sum of all the exterior angles of a polygon equals 360 degrees. And this rule is independent of the number of sides of the polygon. Now, why is this so? Let us go back to our initial example of a triangle. Now, see here in the diagram, I have labeled all the exterior angles of the triangle. And now, if I were to slide the angles along the side which they are formed, you realize they will all congregate at a point, and angles at the point equals to 360 degrees. Now, we can look at another example of maybe a pentagon. And in the pentagon, let's say I were to slide all the exterior angles together, we will also get the same result. And this can go on for any other polygon. And that is the visual proof of sum of exterior angles in a polygon equals to 360 degrees. So how is this useful to us? Let us take a look at worked example 16 of the textbook. And in worked example 16, we can see a polygon, in fact a quadrilateral with two unknown angles, x and y, which are both exterior angles. Knowing that x is an exterior angle will allow us to know that DG is actually a straight line. And this is why we can apply adjacent angles on a straight line to find x. For y, we are not given the interior angle GDA, which is why we have to make use of the property that the sum of exterior angles equals to 360 degrees. So we take the sum of exterior angles and we equate it to 360 degrees. By simplifying this equation, we will get y equals to 64 degrees. Now, we have learned what is an exterior angle and how do I label it, as well as why is it that the sum of exterior angles equals to 360 degrees. And we have learned how to use this result to solve some problems regarding exterior angles. Thank you for your time, and I hope that you have learned more about the sum of exterior angles.